All right, exponential functions. The equation for exponential functions is y equals a times b to the power of x. Does anyone remember what a represents?
The starting number.
The initial amount, initial value, or what else? The starting number, the y-intercept. So on a graph, the a value is our y-intercept, y-intercept. Our b value tells us if it's exponential growth or exponential decay. If it's exponential growth, what do you know about the b value? It's more than 1. It's greater than 1. If it's exponential decay, what do you know about that value? Between 0 and 1, less than 1. Awesome.
Isn't there normally a plus k after that?
What, sweetheart?
Isn't there normally a plus k?
That's quadratics. That's quadratic. So that's y equals a times x minus h squared plus k.
Oh, okay. Sorry.
You're good. Okay, so remember the b value, inside the b value is that r value, that percentage. We'll go over that in a minute. Okay, so what we need to know or remember about exponential functions, is this exponential growth or exponential decay? Decay, because this is going down from left to right. So I know my b value is between 0 and 1. What's the a value? 1. What is the domain of this function? Right, because this is going to the left and to the right forever and ever, so x is all real numbers. Now, will this ever cross the x-axis? No. What is that line called that it will never cross? Horizontal asymptote. Horizontal asymptote. This is a horizontal line, so x equals or y equals equation. Y equals equation. So if it's here, what's the y value at the x-axis? 0. So the horizontal asymptote would be y equals 0. Okay. Can you wait till after the review or no? Okay. So if it's never going to cross this line, what's the range?
All real numbers greater than 0.
Yes. Okay. So all real numbers greater than 0 because it's never going to cross this line, but it's all above this line forever and ever. So it's everything greater than 0. Not equal to, because it's never touching this line. It's everything greater than 0. My sweet loves who I know struggle and you haven't come to tutoring, we have only a few days left, babies. I need you to put the time in and the effort. Exponential growth or decay? Growth, and it's because going up from left to right. We're not going to go over every single thing, but one thing I always notate on my test, if it's exponential growth, immediately I'm writing b is greater than 1. Immediately. And I always, okay, my y-intercept's at 1, so I know a equals 1. Now, a lot of you asked me before, how do I find the equation from a graph? So let's get some points together. This point is at 0, 1. This point is at 1, 2. This point is at 2, 4. So remember, on a exponential growth, we're trying to figure out how much it's multiplying by every time to get to the next thing. So 1 times what will give me 2? 2 times what will give me 4? So I know my b value is 2 because that's what it's multiplying by. And my a value is what? Y. Yes, that's the y-intercept. My a value is 1 because that's the y-intercept. So my equation for this graph would be y equals 1 times 2 to the power of x. Now remember, guys, this is not the time where I'm reteaching. This should be the time of quick review. So if you have a question, you're going to have to ask. If I'm going way too fast for you, you're going to have to speak up for yourself. Okay, moving on. The population in Grand Prairie in 1994 was 48,000. So this was the initial amount. So what does this represent? A. Since then, the population has growth, so I know this is exponential growth, at an average of 3.2% each year. Pause, 3.2%. That's R. So remember, if it gives you a percentage, that's the R value, not the B value. Write an equation to model the growth. Well, I need my B value to write the equation. Y equals A times B to the power of X. We know the A value is 48,000. But if it's, how do I find the B value? If it's exponential growth, what do I do to this number? Perfect. Change it to decimal form. 3.2%, 2 places to the left, 0.032, and then add what? 1. So 1 plus 0.032 would be 1.032. So my equation is 1.032 to the power of X.
Wait, how to change it is on our formula chart, right?
Percent to decimal? No.
Not like the RB.
No, R is not on. No, it's only on the formula chart. The only thing that the formula chart gives you is, the formula chart doesn't even give you anything about exponentials.
What do we do with
Hold on. Yes?
Sorry. So the different ways to get like, I know you do like -1 and all that stuff for different things like decay and stuff, right? Is that on here?
It's on the study guide. Yes.
Okay.
Yes.
well, she answered. I was just gonna say, what do you do for exponential decay?
All right. Perfect. Yeah. If it's exponential decay, you would subtract it from 1. The amount of fertilizer in our landscaping company's warehouses decreases at a rate of 3%. There's my R value. The amount of fertilizer in the warehouse was originally 78,000. What does that represent? A. So I know this is Y equals 78,000 times B to the power of X. We need to figure out B. Well, this was decreasing. So just what I just said, what do I do with this 3%? So change it to decimal and then subtract it from 1. So 1 minus 0.03 would be 0.97. So it would be Y equals 78,000 times 0.97 to the power of X. Questions? Comments? All right. Sorry. That's it. That's our review for exponentials. So now what we're going to do is we're going to play a little gamey game. A little gamey game.